Hey there, everybody.
Hello,
I'm Isaac.
I'm Amanda, and
Yeah,
we're both online course developers at MathWorks. And so I guess we can start by just like introducing ourselves a little bit.
yeah.
Um, yeah, so I've been here at MathWorks for about 2 years, a little bit under 2 years. And so what I do, and which is very similar to what Isaac does, is we do a lot of like course writing. So we write content on Coursera, and so we do things like different kinds of technical topics. So like data analytics related things or like image processing or like computer vision and deep learning. And yeah.
Yeah, throwing those courses up on Coursera. Oh, you have your fun fact?
Oh yeah, sure. So one fun fact that's pretty interesting is just like I actually interviewed for MathWorks. I had my on-site interview the last day when everyone was in the office. So basically like right when like COVID started being more of a thing, at least here in the Northeast.
Before
And
COVID Armageddon.
yeah, and then everyone started
So you
um,
got to see the place.
working offline. Yeah.
I'm Isaac Bruss. I've been at MathWorks for 3.5 years now. And I got my PhD in polymer science and engineering, technically, from UMass Amherst. But secretly, I'd say I'm applied physicist or applied mathematician. I am not originally an image processing expert, but you know that doesn't matter, as we're going to see. There's some cool tools that you can use and figure this stuff out.
Yeah.
And specifically what we're going to do, the project we're kind of going to work through right now is, I'm going to post it in the chat, is from this Coursera specialization, which is on image processing for engineering and science.
Yep. So it's right up here. So if you guys can see, this is the Coursera page.
And Amanda's an instructor. You can see right there. Her little...
Yeah. We're both instructors down here. I just happen to be the one showing there because my name is first. But yeah, so there are 3 courses here. And you might notice like this specialization is called image processing for engineering and science. And that really means like this is kind of like image processing for doing sort of more like science and engineering applications. And we're doing some sort of like, usually doing some sort of like data manipulation and then like analysis after processing images. So it's not like any sort of like Photoshop course, like we're trying to remove like red eye or anything like that, or like removing blinks or stuff like that.
Yeah, go somewhere else if you want to do that. Want to edit the dog out of the background of your picture or something.
Yeah.
I mean, technically, I suppose you could do that too, but
yeah, not the focus of our course though.
If you want to count the number of pixels the dog occupies in the photo, then stay here.
Yeah, so let me just pull up a couple of examples. So we work with a lot of different kinds of images in this course. And these are just a couple that I had pulled up, but you can see like we do some like satellite images, some like medical images, like DICOM images, X-ray image, like concrete crack images, and then just like different kinds of images that you might encounter if you're working as an engineer or working as like a researcher in some technical field, STEM field, I guess. But, yeah.
So what are we doing today? Let's get there. Yeah. Let's show people.
So today we're going to be working with, let me pull this up. We're going to be working with these 2 images. So let me just show them side by side. We're going to be working with these images of an ice shelf in Antarctica. So you can see like on the left, we have an image taken in 2018. On the right, we have an image taken in 2020. And so like this is showing the exact same location, the George VI ice shelf. And one thing you probably might notice immediately is like this image on the right has a lot more blue specks, bluish, light blue, dark blue specks than the one on the left. And so that's meltwater. You can probably see it if you guys like zoom in further. Isaac, you can drop it in the chat.
These things are melting.
Yeah.
Good news, everyone.
Yeah, so we can clearly see that they're melting. And the first time I saw these images, I was like, wow, they look so extreme that like maybe one's taken in the winter and one's taken in the summer, right? Because because that's, I don't know, usually how I feel like there are like really, really big differences in such a short time frame, but they're only taken a few days apart.
Yeah, 2 years apart, but a few days of January.
Yeah, both in January, so.
Which is what, Antarctic summer, right? Flip it from us. Oh, I'll also post that to the chat if people want to see that. If we want to grab the images themselves, you can right-click, save as.
Yeah. Or you can like do this like curtain view if you want to see like them literally on top of each other, and you can see like the rocks lined up and everything, right? Like this is.
Yeah. So what we're basically going to do by the end of this little session is measure the amount of meltwater on this ice shelf. How much has melted by area? Basically, more or less counting the pixels and how many more blue meltwater pixels there are. And we'll all be depressed by the end because the Earth is warming up. Yay!
Yeah, so let me just pull up MATLAB. So yeah, I think you can start.
Yeah.
You can start
let's do that.
MATLAB, right?
I'm smiling as I say this because my daughter was up with a tooth coming through, and so I'm like 110% powered by Mocha right now. My camera starts jittering. It's, my legs bouncing on underneath the table probably. Yeah, let's get to it. So we're measuring the amount of meltwater on this ice shelf.
Yep.
And we gotta load them up. So let's look at these images.
So we already have these images here, as you can see, like in this current folder that we're in. So we can like take a look at the images by going to one of the apps in MATLAB. So you notice like if I go to the apps tab and then I go in here, there are like a lot of different apps that we can use. And so we're gonna be working with 2 today, but like, I guess mostly you might like working with apps just because I feel like they help you explore the data a lot better. Like they help you get a really good sense for how you might want to start working with your data, and then it's pretty like exploratory, I would say, frequently. It's like,
yeah, I mean, this
nice
is like what I use because I'm not a programmer by trade and I'm not an image processing expert by trade. But hey, there's these kind of graphical interfaces that you can use to do image processing. Makes it nice and handy. Hey, if you like the code workflow, you can always just export the code anyway.
Yeah.
And go from there. So they go hand in hand. But we're going to open this up in the tool because it gives us a neat little way to visualize the individual pixels. And I'm just going to blow this up.
Yeah, I just opened this up in the image viewer app. Let me actually just move this here.
And this is the second of the 2, right? Yeah, the more meltwater.
Yeah, so this is the one that has a little bit more blue. Cool. So first thing we're going to do here is we can like take a closer look at some of these pixel values. So this app is pretty useful for like if you want to take a look at different regions in the image, like a closer look. You can like move this little box. You see this like little blue box thingy? I'm dragging it around, and then I can see like, oh yeah, like on the right here, we can see the actual like RGB values. So for those of you who might not be familiar, like RGB is like stands for red, green, and blue. There are like 3 color channels that you can use that is frequently used to like represent color images, color like things that need 3 like things that are in color, not grayscale. Yes. So.
Yeah, so we can see here, the white snow pixels are bright, so it's got a lot of RGB high values. The rocks are dark, so those are going to be low intensity values for R, G, and B. And you want to find the specific pixels that are the kind of bluish ones here.
Yeah, so our goal is to try to like have some sort of like segmentation thing to like we can differentiate between these like bluer pixels that you can see here versus like these actually look kind of pink and purple, but I think they're probably bits of snow. Yeah, it's pretty cool because it doesn't look like we would never say that it looks pink or purple from here, right? But I guess if we zoom
That's where a polar bear, had its meal. It got a little stain there. Wait, so that's not Antarctica, is it? Darn.
It is. Wait, is it? No, it's not. Right? Polar bears are in the Arctic, and then elephants are in
or the tropical Lost Island. Either way.
Yeah. So you can zoom in and out as much as you want, but to see the pixels a little bit more. Cool. So maybe we can go into the color thresholder app and take a look.
Someone did make a comment about the text being a bit small. I don't think we could necessarily change it in the app, but if you do Control+ here, we can probably make the it larger for the live script. That should help.
Yeah. That'll be too big.
Yeah. So that'll make that bit of code better.
Yeah. Also just.
All right. So how do we isolate the meltwater in these images so we can measure how much of these George VI ice shelf is melting?
Yeah. So the next thing we're going to use is this color thresholder app. If you saw that, I clicked it open from here. And so first thing we have to do is just load in the image. Let's load in the same image that we looked at before.
More melty one. Yeah.
The 2021. And so we can see like all of this stuff popped up, right? We have these 4 different color spaces we can use. RGB, HSV, YCBCR, and LAB. And so these are 4 different kinds of like color image representations. And so we can use a couple of these to try and like differentiate the light blue and dark blue like meltwater pockets.
How would you say it? Yeah, basically, so each pixel of the image is a color, and so for RGB, you split those axes into a 3-dimensional plot, and so each pixel is placed where it's the red value, green value, and blue value. So yeah, Amanda can rotate that around, and you can see where the pixels are located in this color space. Yeah, and then there's HSV, which is hue, saturation, value. I want to say volume, value. And other color spaces too. YCBCR, I think that goes back to, that's an older one with like TVs and how it transmitted signals, I think. I forget what the acronyms stand for. I think Y is yellow.
Yeah.
And LAB is one of my favorite. I think A and B are just mathematical variables. L is like lightness or something. Anyway, it's transformed, the coordinates are transformed such that it's the most
perceptually uniform.
Perceptually uniform distribution of the colors. That might be a little more clear when we get to one of the other color spaces.
Yeah, I think it'll be clear when we get to HSV a little bit more.
Yeah. So this is helpful. If we want to, isolate these blue pixels from the water, we need to segment them out of this color space. And then we can create a mask or kind of isolate these pixels and then count them and compare them between the 2 images.
Yep. And so we can just get started with RGB.
That's basic. Yeah, that's what our computer pixels use. They have the right green, blue pixels.
So let me just full screen this so you guys can see it a little bit better. So yeah, so you can see immediately here we have this image shown on the left. And then you might notice like we have a few of these sliders, like histograms on the top right. So we have, this is RGB. So we have 1 histogram for each of these 3 like color channels. And so like these spikes just mean there are a lot of pixels that have a B value of like 200-ish.
Right. And the typical is what unsigned integer 256, right? There's 256 values that a pixel can have in each channel. And so if it's 0, it's black. If it's the high end, then it's maximum blue, green, and or red. And this histogram lays them out.
Yeah, and just to recap quickly for those of you who might just be joining right now. So we're working with 2 images of an ice shelf in Antarctica, and we're trying to like segment out or like pull out or like differentiate these like light blue, like meltwater pockets versus the snow and the rocks and some of these clouds over here. Yeah, using different tools and different like color spaces and stuff.
Mention this thing is massive. The width of this ice shelf, not the length, but the width is like 10 miles or something. Like,
do you want me to pull up the Google?
This is not a little lake. This is a big hunk of ice that is melting. Oh yeah, here's our Google Maps. If you're curious where on Earth we are.
Yep, so right down south of Patagonia.
That nice little, yeah, and you can see that big dark chunk of rocks to the like northwest of the red marker. You can see that same chunk of rocks there. Yeah, you see the bar in the bottom right. That's what, like 20 miles across. Yeah, it's like 10, 15 miles.
Yeah, it's really huge. And it's like all this, I think, is the sound.
That's a lot of water.
Yep. Okay, cool. So
let's segment that water.
Yeah, so we can start by just playing with a couple of these sliders. So you see, like, we can kind of pull these sliders to like segment out part of it. So like to remove part of it from the image. And so let's say we want the blue. So let's try getting rid of this.
Yeah, so Amanda's segmenting out. So that big peak on the left, that skinny, tall peak on the left is the black or darker pixels of the rocks.
Yeah.
So she's excluding those by including everything in the window, because we want to segment out, isolate everything in these slider windows that Amanda's dragging. So we want the blue because of the water. She's playing around. We want the the bloody snow left by the polar bear, our hypothetical polar bear. Probably not. We'll drag that around, try to get out some of the red, green. We're getting some of it, but I'm noticing a lot of rocks.
It's not that bad, but let me just change the opacity also so you guys can see. So like if I change the opacity, you guys can see more clearly, like these are the points that we separated out, and then we can also see the background behind it. So I really like this view in general because it helps.
Yeah, the common terms are what foreground and background in image processing. We want to isolate the foreground, or which in this case of the meltwater, and turn everything else black, basically, so that we can just look at the water, the meltwater on the top. And you can change the opacity of this mask, is what we would say, that overlays the image. I mean, I'm even seeing that it's like some of the icon or sign in the top right was being picked out originally. Oh, you got rid of it now.
Yeah, but I think I got rid of a lot.
You got rid of too much water. Yeah. All right. So this isn't working that well, is it?
Yeah.
But hey, that was just RGB, right? Why wasn't that working?
So wait, let me see. Yeah, it's because like if we take a look at the pixels values, so you see here, like when we're trying to segment out the meltwater, we like just try to use these three thresholds to be like, oh yeah, if the blue value is above this, that's foreground, or the green value, if the blue value is above this and the green value is below and the red green value is below, then it's foreground. But as you can probably see from before, when we were looking at these pixel regions, we can see that the RGB values kind of range a lot. Like this.
Yeah. Can you say some numbers just for the people that can see the text size? Sadly, the font doesn't grow when you zoom in.
Yeah. Oh. Wait, what do you mean?
So the blue is what we think is blue is like I'm seeing like a green channel 146, red channel 87, and blue channel 190. So if there's a lot of green and blue in what looks just blue, right?
Mm-hmm. Yeah, and then some places that we think are really blue are just like the green and the blue values can actually be pretty close sometimes. Yeah,
like even if you scroll down one row more, there were those pixels that are kind of turquoise, tropical colored, and those have higher green values. Like I'm seeing green 179 and blue 178. So that's more green, and red is 129. I mean, that's like pretty high in all three.
Yeah, and then we can see for the lighter ones, like the red is just 138. But it would look like the cell looks blue, but the red value is like 138 or 161. And then if you just heard that, you might be like, oh yeah, that sounds very red, right? Because the red channel is so high. But it does look blue for the most part. And then the green value is also high, 184. Blue value is 210. But
yeah. So the moral of the story, unless you have objects that you're trying to segment that are like very red, blue, or green, maybe another color space.
Yeah.
Will serve you better.
Try HSV next?
Yeah. So RGB, you'll see in the tab, is still saved on the left there, but we'll do a new one with a hue saturation value.
Yeah.
See if we can do some better work here.
So yeah, one thing that we can do, so you can notice like here there are new like slider things that we can adjust, right? So for hue saturation value, we have hue, which is this like color wheel thing. Saturation and value here, which is like basically how dark or bright and like how saturated the image is. So if we're trying to segment out the blue meltwater, one thing that you might think is, okay, let's just highlight all of the bluish ones, right? Like all the bluish areas on this color wheel.
I want to say grayish, greenish blue. That's a good description, yeah.
Yeah.
That's an official color.
Like, this is still has a lot of patches of not really blue. Like big patches of snow that are also selected with this.
Still have the S and V channel, but we could play around. So saturation, like how much color, and V is like the brightness. So we could like try to get rid of the bright snow maybe, or the unsaturated snow. There's actually another cool technique that you can do.
Reset. And so one thing that you can do is like, there's a little button up here that you can select regions. And so let's zoom in here. So if you select regions of, say, blue here, like these blue pools, it will just try to segment all colors that look pretty similar to these.
Yeah, within this, lassoed region that you make. So yeah, Amanda's going to draw. If you can see it, she's drawing a blue line over the blue water, so it's a little hard to see, but she's basically defined an area of pixels. And hey, look at that. All the slider bars for HSV channels kind of auto found their values that isolate these pixels.
Yeah, so all I did was I took this big pool and I like circled a lot of it, and yeah, seems to have done a lot, and then like also segmented out a lot of like identified a lot of the blue chunks, but not all of them. As you can see, like these are all missing on the bottom.
Yeah, a lot of it dark.
Yeah. A lot of the dark ones, and also some patches of lighter ones too, I think. Like really light blue.
Can we capture those?
Let's try doing another. Let me know if you see a good patch. Maybe this one?
Well, if you want the dark, so on the left there's kind of the big one.
This one?
Yeah.
I'll do that one, and then I'll do
oh yeah, you can see, so the mask is overlaid with some opacity here, so you can see some of the lighter pixels are captured. Now you can see more of them. So this
so this looks a lot better.
Yeah.
I guess.
Yeah, we can play with the opacity some more, see what we're missing, but we're doing a better job. We're still missing a lot of that dark water.
Yeah, let me try to get one of these blobs.
Because they're so thin, you might have to zoom like another level.
Oh my gosh, this is too much. Okay. Let me try this.
I feel like this is looking at clouds in the sky. I'm seeing shapes. I'm seeing like a fat whale and a seahorse in one of these shapes. Anyone else? It's just me. Maybe that mocha's making me hallucinate. All right, so Amanda's adding some more little regions.
Too much. Okay, that's fine.
Yeah, is it too much? You captured a lot of
too much, I think.
white, but not all the snow. Yeah, you did a pretty good job. click on the binary button. I'm just curious how it goes. So if you do the binary, it just shows the mask itself. That is, the white pixels are what we're trying to isolate, and black is everything else.
So we do get some specks up here and down here.
Yeah, we are getting some of the rock. Should we try the other color space?
Yeah, sure. So let's.
Yeah, we can play around with this some more. You can even, delete some of those regions Amanda drew and restart, or click and drag them around to shape them. But
yeah, and I really just like we can always like go back and like change things up, right?
Yeah, try to
compare
improve
them
the RGB.
Yeah.
Yeah.
So let's start LAB now. And so for this one, we can try like a similar technique, but instead of trying to select the regions that we want, we can try selecting the regions that we don't want.
Yeah.
So
can I jump in with why LAB is cool?
Yeah.
Yeah, go back to the HSV one because I like the color wheel. So if you look at the color wheel for hue, you'll notice that like different colors perceptually, like our mind or vision sees big changes in the color as actually not being that big. So you'll see like yellow only occupies a tiny sliver, while like darkish blue occupies like a big, almost like third of that color, or a quarter of that color wheel. And so what are actually significant changes in the values of blue, our eyes don't perceive as actually that significant. But for yellow, or like maybe the like pinkish kind of, those are like narrow bands. There we have a little change in the value of hue, and our eyes really pick up that change. So LAB color space is cool because it it accommodates for that. It kind of mimics tries to match what our eyes see, and it evenly spaces out those colors using these three coordinates, L, A, and B.
Yeah, and I feel like you can tell a little bit from this point cloud. Like the points are a little bit further away, like the green ones are all the way over here.
Yeah, L is basically intensity. So if she has it oriented kind of north-south, the white pixels are at the top, the black pixels are at the bottom.
Yeah.
And the other pixels are in the middle with saturation. And the colors there are kind of use the A and B, which don't stand for anything, I don't think. They're just kind of variables. So it's a handy, very useful color space to use sometimes. The nice thing about this app is you go in, you have no idea what color space is going to work beforehand.
Yeah.
But you just try them all.
Yeah.
Piece of cake. So you're going to show them this handy little trick.
Yeah, so we were going to just try also doing this sort of like same select a region of colors using this button here. And so let's just try selecting a lot of stuff that we don't want. So like basically some of the text and some of the rock, some of the snow, some of the clouds, question mark, I got in there.
Can you tell cloud? I can't tell what's clouds. All right.
I think these fluffy things are clouds, right? The little, do you see those? I don't know.
Yeah, you might be right.
But then we can do invert mask. And we can see that this looks pretty good, I would say.
Yeah,
so just like drawing a big circle.
Yeah, you're trying to draw tiny circles to get the little slivers of water, melt water, and spending all that time. You could just select everything you don't want and then flip it.
Yeah.
And reverse it.
Mm-hmm. Yeah, so let's just take a look. Yeah, I think it seems pretty good.
Yeah, it's capturing some of the white, but only the whitish snow that is tinged blue, maybe from the thin layer of meltwater.
Yeah, and then it misses some of the streaks of dark blue. But...
Yeah, it's missing some of those, but yeah, I'm okay with that. So this is from what? This is from the Coursera course. This is actually a mini project in the course that you can do. And it's more in depth than what we're doing here. So we're not going to give you the answer.
Yeah.
Which color space is best?
Yeah, a lot of it's also just like refining, like your first attempt might not work well, so you might want to keep refining using these, using more regions, using like different techniques. So that's a lot of what you might do if you really wanted to implement this model.
Yeah, yeah. There's kind of this overall thing I've learned when doing image processing is there's like 10 ways to do something, and you might not know which way is the best way until you start doing it, because images are, complex data structures. Yeah, so this kind of makes it a nice, easy way to figure it all out.
Yeah.
Make those mistakes.
Next, let's just make sure. So next thing we can do is we can export the function that does this sort of like isolating of the meltwater, just in case we want to use it later, or we want to refer to it later or something.
Well, we do want to, because we've only done this with one image. We want to do it for the other image.
So yeah, it's just pretty helpful if you press export function. And let me know if you guys want me to zoom in more too, and you can't.
Oh, that's plenty. You could even zoom out one level probably.
Yeah.
Yeah. For those of you who might have joined late, we have these two images of meltwater of a giant glacier ice shelf, and not glacier, ice shelf in Antarctica. And we're trying to isolate and measure the amount of melting that has occurred over a 2-year period of this George VI ice shelf that is massive.
Yep.
And prove that the Earth is warming. Hopefully prove that the Earth is warming.
Yeah, so let me just copy this function. So this was the auto-generated function, right? And this is also one reason why using apps is pretty helpful sometimes, because if you don't want to like write this yourself and like defining thresholds, and you might not know like what values you want for thresholds exactly and stuff like this, you can use the app and then just export something.
Yeah, which is kind of neat. You can fine tune things here, and you can do everything we did in the app by code if you knew what you were doing, or you just export it, and there you go. And now you have a function that you can use on any image. You can isolate meltwater and photos of your cat, if you so choose.
Yeah, so I just read in these two images. The first one is the 2018, second one is the 2020 image. And so what do we want to do?
Yeah, she's using the mread function to save those as two variables.
Yeah. So let me just, I'm going to change this function name to something a little more descriptive. Like, which one was this one? LAB, right?
Yeah, we exported the LAB mask. And for those of you who haven't noticed yet, maybe we're using a live script and embedding a local function at the end of the script, which then can be used in the script. And this function will take an input of an image and export a mask, isolated pixels that we use the app to find the meltwater.
Yeah, and so you can see here, I saved them as BW1 and BW2, and they're both like logical arrays, so just a bunch of zeros and ones. If you want to look.
Yeah, I always thought this cool. We're in MATLAB. The MAT stands for matrix, so it's pretty useful, fast, handy way to analyze images, because they're essentially matrices. That's what computers see them as, is to use MATLAB, the matrix laboratory.
Yeah. So let me just close that out. And let me just show, so we developed it using the second image. So let's just see the first image.
2020 image. So let's see how our mask did on the 2018 image. We haven't seen it yet. We just made the mask using the second one that had more meltwater. So this imshow pair function puts two images side by side for viewing.
Yeah, and then we use the blend option.
So yeah, in this case, not side by side, because we're using the blend option. There's lots of, you can put them side by side with the montage option. You're a quick typer. right as I say it. Look at that. So they're side by side. The mask on the right, which is black and white, kind of overlaid, and the white pixels would be the meltwater. And then I like what Amanda had first.
We do the blend.
Is the blend, and then we can see the mask applied to the image to see how well it did. That did. This is kind of better than some of the times we practiced before.
Yeah.
I'm impressed. Maybe we lucked out a little bit there. I mean, we're getting some of the snow, but I'd say it's the snow that's only around the meltwater, which is probably just like shallow meltwater.
Yeah.
We are missing some of the darker ones.
Yeah, I agree.
Yeah, but hey, as we said, this is part of the Coursera course as a little mini project. So we're not going to give you the values that you need to do this project.
Yeah.
I'm okay with it, with our first pass.
Yeah, and if you wanted to explore this more, you can always like just try to refine the functions a little bit more, play around with some more color spaces and everything, and then see.
Yeah, that's right. It's a piece of cake. Just go back in the app, change the sliders, re-export, and try it again.
Yeah, and I think you can also have multiple tabs of the same color space, if I'm not mistaken. Right, like you can have 2 different LAB tabs.
Oh yeah, we could try another one that instead of selecting the negative space, select the positive space.
Yeah, so if you guys wanted to do that,
as opposed to everything else. But we're doing good on time. Let's find our results. How much has George VI ice shelf melted? Why is it named after him anyway? What did he didn't go there.
George VI. Who's George VI? Is he the dad of Edward VIII?
Who's Edward VIII? That didn't help me.
Oh, I think it's like just one generation up from Queen Elizabeth, but yeah.
You got me beat. You got me beat in numbers of pi known, and you got me beat in English royalty. I'm just the colorful humor here. And you're, controlling everything. What am I doing here? Yeah, what are we doing? We're counting the number of pixels, the number of blue pixels that we're trying to analyze how much this ice shelf is melted. Surface area. We can't do volume because our image isn't 3-dimensional for the satellite image. We don't have that technology yet.
Let me make sure.
So yeah, we have
I use the NNZ function with the logical arrays just to count how many basically non-zero, or how many like pixels are blue, or like I guess identified as blue by our function. So
yeah, could you hover your mouse over like BW1 for just a second? You showed this earlier, but just to make this clear, yeah, BW1, it's a variable, it's a logical array, zeros and ones. So NNZ is counting the number of non-zero NNZ elements in this array. The number of ones, and the ones signify the meltwater that we found using the color segmentation app. Amanda's going to do the IMSHO pair for both. Yeah. So here, side by side, the 2 different years, 2020, 2018.
Yeah, so you can see like the number of like identified pixels seems to have increased a lot, but we can actually calculate just like how much it's increased by if we like want to calculate a ratio. So it's like number of pixels identified here is about 4 times.
Yeah, so
right here.
4 times the meltwater in a 2-year span on this ice shelf. I was in the back of my head worried that we were going to find a ratio below 1, and that global warming conspiracy deniers are going to be like, "Hey, scientists disproved their own conspiracy of things are getting colder," or something. Oh, all right. So things are happening the right way. We're agreeing with science. Things are melting. Sorry, everybody.
Yeah.
Someone did make a good point on the chat that when looking at the thresholds or applying this mask to the two different images, they're saying HSV definitely be better with RGB. I would agree, especially because V, the not the volume, the value
yeah.
Does change significantly between these two images because of different lighting conditions, which are totally true. These are different times of day. You can notice like the shadows are cast slightly different between these two images. And so, yeah, HSV is probably a good color space to do this. And LAB could be a good choice too. But yeah, again, you don't know that beforehand. So try them both.
Yeah.
We're getting some updates from those in the background doing the fact checking. George VI was Queen Elizabeth's father, according to Wikipedia. Yes.
So who was George? Okay, whatever. I'll figure it out later. But also.
Yeah. Hey, we did it. Yeah, we got it. We figured this out. So we know how much this ice shelf has melted over 2 years. We got kind of a ratio of how much the meltwater has grown surface area wise.
Yeah, and so I guess we can just go back to the specialization for maybe those of you who didn't join at the beginning. And so this is just one of the projects that we work on in this image processing for engineering and science specialization. And so I guess one thing you probably noticed is like the engineering and science is because this is an image processing course for like engineering and science applications. So more like analysis related things, like more like just different kinds of, I guess, engineering. And we work with a lot of like medical images, satellite images. I guess like we have concrete crack images, we have videos, we have different kinds of videos.
Images.
Yes, that too.
Yeah. Oh yeah, here are some examples. Show up the final project, which is kind of cool because I wrote that part of the course. I think it's the best part of the course, obviously.
It's very cool though.
So, you know, if you take the specialization, which has 3 courses in it, the final project that you're going to do is isolate the cars driving by in this video. You're basically doing detection of cars in sorts by segmenting them out. And the process to do it here, you'll notice you're, detecting black and white cars in this video. This is an animated GIF showing some frames. You draw a little bounding box around the cars. Color thresholder app wouldn't work for this case because, there's dark shadows and white concrete, or there's even some snow on the sidewalk because we're in Natick, Massachusetts, and this was semi-winter. So what we did here is background subtraction. You have this video, you can subtract out the unmoving background and then isolate the cars, get that mask. Same result that we got for the meltwater here, but a different process to get it. Makes a cool little project at the end, which you can practice doing.
Yeah, so I think this is a super cool final project. I just really like the way this looks, like with the bounding boxes and everything. But...
yeah, I can quantify that traffic heading by our office, and you can see the MathWorks sign there. Yeah. Someone did ask before we close out, like how to obtain these images for other geographic areas. We do have in the course another kind of little project, I think involving there's a flood on a river in the Mississippi River.
Yep.
Right, the bottom
These are the
2 images.
Mississippi flood images, yeah.
So similar kind of idea, see how much more water there is from a flood. And then if you want the images that we got specifically for what we did today, I just posted it again in the chat. It's from NASA. You can get those. If you go through that website, there are other options. You see the climate.nasa.gov, images of change.
Yeah.
There's plenty of things here. This is rain
This is a
floods.
flood in Sudan, South Sudan.
I'm sure there's others of like deforestation or
Yeah.
wildfire coverage, things like that we can do before and after and play around with intensity or color thresholding to try to quantify how much damage humans are doing.
Yeah, and I think a lot of them are basically the same image taken a couple of years apart, so you can do this sort of like similar comparison thing that we did today.
Yeah. That's more or less what we wanted to walk through. Thank you, everyone, for joining. If you have any final questions, now's the time to type them in before we sign off.
Yeah, and I guess in the meantime, do you want me to show the brain MRI? Because I always thought that's cool.
Oh, yeah. Yeah, medical imaging is obviously a major player in image processing for science and engineering. So we, in this course, have some examples that are medical images. This is a 3D image, MRI of a brain. Someone's brain that I know, but I won't tell you who. Very healthy brain, I would say. Works very well.
Cool. Yeah. So this is just one like sort of cross section, but just like this is super cool in my opinion.
Yeah, it's 3D image going through the brain. So, want to learn about how to make this animation and stitch together 3D or 2D slices of the brain into 3D images? Here you go. Yeah. All right. I think that's it for today.
Yeah. Great. Thank you guys for joining, and check out the specialization if you thought it was pretty cool and want to see more projects like that.
Yeah, we're on the forums on that course, so you can chat with us there if you have any questions in the course. We're involved there, and yeah, thank you everyone for attending.
Thank you.
Adios. What's our sign off? Good night and good luck. We can say toodaloo.
Yeah. Bye, guys.
Take care. Bye.